Okay, in this video we're going to look at areas of circles and sectors. Example 3, a circle is inscribed in a square. Each side is 10 centimeters long. What's the area of the circle? Well, area of a circle is pi r squared. And I know if the side of the square is 10, that means the diameter is 10 and the radius is 5. Therefore, area equals pi times r squared, or 25 pi. This simplifies to 78.5 centimeters squared. Example 4, find the area of the shaded region. Well, area of the shaded region is going to be area of the square minus area of the circle. The area of the square is s squared, the side squared, so that would be 10 squared minus the area of the circle that we just found, and that gives us 21.5 centimeters squared. Area of a sector. The area of a sector is the area bound by two radii and the arc between the endpoints of the radii, as shown in the drawing. It's a part of the area of an entire circle. The area of the sector is the central angle divided by 360 times pi r squared. So in example 5, we're trying to find the area of this sector with a central angle of 60 and the radius of 8. We just substitute 60 and 8 into our equation and simplify. And we can leave our answer in terms of pi. It would be 32 thirds times pi, which is about 33.5 square units. Example 6, the area of a sector is 8 pi and the radius of the circle is 12. I can make a little sketch here to show you what we're looking at. And I'm trying to find the central angle, which I've labeled as x. So this time I substitute in my area of the sector, 8 pi, and my radius, which is 12, and I'm looking for the central angle, x. Pi's will cancel out on both sides of the equation, and I can simplify and solve for x by multiplying times the reciprocal, and I get 20 degrees. Example 7, the area of the sector of a circle is 50 pi and its arc length is 5 pi. Find the radius. Well, we know both of these equations. We know the area of the sector equation and we know the arc length equation from the last section. So if I substitute my knowns, I end up getting two different, I get two unknowns. One's the central angle and one is the radius. So if I have two equations and two unknowns, I can solve for one of the unknowns by using the substitution method. I'm going to simplify the area of the sector equation and then take my arc length equation and I'm going to solve for the central angle. The central angle is 900 divided by r. Now if I take this 900 divided by r and substitute it in for the central angle for the other equation, I'll end up getting a simplified r equals 18,000 divided by 900, or 20. So I had two unknowns and two equations, and I end up getting one unknown found. And I could find actually the central angle if I wanted. A chord is a segment whose endpoints lie on the circle. So here's the chord. The area bound by a chord and the arc with the same endpoints as the chord is called the segment of the circle. Okay, so in example 8 we're going to find the segment of this circle below, this blue area. Well, the area of the segment is going to be the area of the sector, which is that whole area swept out by the two radii, minus that triangle. And we know the area of a triangle is 1/2 base times height. So I'm going to redraw the triangle with an altitude here, which ends up being the height, which will bisect at 120 degrees, giving us a 30, 60, 90 triangle. Well, I know the hypotenuse is twice the short leg, and the long leg is short leg root 3, so I can find all my sides that I need. If you don't remember the special triangle relationships, you can use SOHCAHTOA. I can use cosine 60 equals h over 24 to find the height, and I can find x by using sine. And the sine gives me about 20.78. If I double that, it'll give me the whole base. I'm going to use my exact measurements from the special triangles in the equation. You can use the decimal rounded number if you wish. So area of a segment is going to be the area of the sector minus the area of the triangle. I simplify the equations, and if I want to round it, I got to put it in my calculator. I get 353.8 square units. And that's it.